Right, we are going to start talking today about function transformations. This is when we take one of our parent functions and we manipulate it a little bit. These transformations can look like shifts, vertical, meaning up or down, or horizontal shifts, left and right. We can also reflect across our axes, either the x-axis or the y-axis. And then we can also stretch it vertically, shrink it vertically, or stretch it horizontally and shrink it horizontally. So what we are going to look at today is how do we know which transformation is happening and how does that change the look of our graph. So we're going to relate each of these to a parent function you're already familiar with. So starting with vertical translations first. This again is a shift up or down. If I have my parent function, any parent function, and I'm adding a number outside, that is going to indicate a shift up. So this is your generic function notation. When you have your function and you add a number outside, we're shifting up. So if I have my parent linear function, f of x equals x, remember that is just our linear line with a slope of 1. It goes through the origin 0, 0. If that is my parent function, and I am now given x plus 2. That plus 2 on the outside indicates that I'm going to be shifting up 2. So instead of passing through the origin, it's going to pass through 0, 2, and that is the only thing I changed about this graph. It still maintains its shape. We didn't change the slope, we just shifted it up 2 units. Okay. Similarly, if you have your function and outside you're adjusting it, but with a negative, that means you're going to be shifting down. So this is again that generic function notation. Now let's relate it to one we know. This is our cubic parent function. And it kind of looks like a parabola where the other half flipped upside down. And it also passes through the origin. So there's my parent function. Now if I am given the function x cubed minus 1, that means I'm going to take my same cubic function and shift everything down 1. So it's going to maintain its same shape, but everything just shifts down 1 unit. Okay. Now when you add or subtract inside your parentheses or inside your absolute value, that is going to indicate a horizontal shift. If you are subtracting, that means you're shifting to the right. So here's your generic function notation. Inside I'm subtracting a number. So let's relate this to our quadratic parent function. Remember that is just our parabola that goes through the origin. Here is the quadratic parent function. And then if I was given x minus 2 squared, again the 2 being inside the parentheses, that means it's going to shift 2 to the right. So my vertex, instead of being at 0, 0, will be at 2, 0. And the rest of it stays the same. It keeps its same shape. Now if you have inside but it's a positive value, that means you're shifting to the left. So let's take our logarithmic parent function. And remember this one passes through 1, 0, and then approaches the y-axis but never quite crosses it. That's log of x. If I want to now graph log of x plus 3, again that plus 3 being in parentheses, that means I'm going to shift 3 to the left. So it's going to pass through negative 2, 0 instead. And instead of not quite crossing the y-axis, I'll have a vertical asymptote at y equals negative 3 instead. So those are your shifts. Again, we have vertical and horizontal. Moving on to reflections. If you have a negative, that means you're reflecting. If the negative is outside, then you are reflecting over the x-axis. So here we are going to graph an exponential parent function. And remember, this one passes through 0, 1. It never crosses the x-axis, and it's increasing. If I put that negative in front, like negative 2 to the x, then that means it is just going to mirror over the x-axis and essentially flip upside down. So it will pass through 0, negative 1 instead. Still doesn't touch my x-axis. And there is our reflected function. Then if I put the negative inside, that means I'm reflecting over the y-axis. So let's look at that for our square root parent function. Again, that starts at the origin and is increasing toward the right. If I'm now going to graph the square root of negative x, that's going to reflect over the x-axis and mirror the other way. So I'm still going to start at the origin, but I'm going off to the left instead. Okay. Vertical stretches and shrinks. If on the outside I am multiplying by a number, that is going to indicate a stretch or a shrink. We have to look at the value of that number. If it's greater than 1, it's going to be a stretch. So if I've got here, we're going to look at our absolute value parent function, which looks like a V starting at the origin. If I instead am going to graph 2 times the absolute value of x, that means I'm going to stretch vertically. I'm going to get taller faster, and that would be by a factor of 2. So all of your y coordinates would be doubling because this is a vertical change. Okay. Again, if I'm multiplying by a number on the outside, but it's a number less than 1, as in a fraction, then that's going to be a vertical shrink. So this is my cube root parent function. And remember, it looks kind of like a sideways cubic. Still goes through the origin. If I want to now graph 1/2 cube root of x, that means that the shape is going to still maintain, but it's going to be a little bit shorter. My y values were reduced by a factor of 1/2. They were all divided in 2. Okay, horizontal stretch and shrink. Inside, I am multiplying by a number. If that number is a fraction, as in less than 1, it's going to be a horizontal stretch. So again, this is our linear parent function. We already looked at it earlier. If I've got 1/3 x that I'm going to graph, that means I have a slope that is less steep. I got stretched horizontally. I'm getting wider faster than I'm getting taller. And then again, if you're multiplying inside but the number is greater than 1, that is going to be a horizontal shrink. So we've already seen this quadratic parent function earlier. We know it's a parabola going through the origin. If I'm instead going to graph 3x squared, again, the 3 is in the inside, that is going to be a horizontal shrink, meaning it is not getting as wide as quickly. Your x coordinates were reduced by a factor of 3. They were all divided by 3. So these are just some examples to give you an idea of what these transformations look like. There can be more than one transformation done to a function. You could have stretches and shifts. You could have reflections and shifts, etc. And one thing I do want to point out is that anytime it is outside the change, again, you're adding, subtracting outside, your negatives outside, you're multiplying outside, that's going to be a vertical change and will affect your y coordinates and possibly your range. Whenever the change is happening inside, adding, subtracting, the negative is on the inside, you're multiplying on the inside, those are horizontal changes. Your x value is what's going to change, and your domain could possibly be what's changing.